Error detection and correction. In this video, we will see some error detection and correction methods. Two types of errors are possible in the data transmission. 1. Single bit error, where only one bit in the data unit changes. 2. Burst error, where two or more bits in the data unit changes at a time. There is no guarantee that every bit that has been transmitted from sender to receiver reaches accurately. Some bits may get lost in the transit, some of them may become corrupt in the passage. Many factors can affect one or more bits of a message. So we need a mechanism for detecting and correcting errors. The main concept in detecting or correcting errors is redundancy. We need to send some extra bits, that is, redundant bits, along with the original message, in order to get detected or corrected at the receiver. Usually, errors can be corrected mainly in two ways. 1. Forward error correction. 2. Retransmission. In forward error correction (FEC), the receiver guesses the error by using redundant bits and corrects the error immediately. It is possible only when the number of errors is small in the message. Well, we will see why. Here, the packets are sent in groups, with each group containing 4 packets. For every 4 data packets that are sent, a fifth parity packet can be constructed and sent. For example, L, M, N, O are data packets, and P is the parity packet, which contains redundant bits that are the parity or exclusive R sums of the bits in each of the 4 data packets. If all of the packets arrive safely, the parity packet is simply discarded at the receiver. Or, if only the parity packet is lost, the receiver knows that the lost one is parity, and the original bits are safe, so everything will be okay. If any packet is lost during the transmission, the bits in the missing data packet can be reconstructed using the parity bits, and other 3 packets. If 2 packets in a group of 5 are lost, there is nothing we can do to recover the missing data. That's why it is only possible when the number of errors are small. FEC techniques are valuable, because they can decrease the number of sender retransmissions required. And more importantly, they allow for immediate correction of errors at the receiver. The ability of the receiver to detect and correct errors is known as forward error correction (FEC). Since it corrects the errors, it is called error correcting code. In retransmission, the receiver detects the error and requests the sender to retransmit it until receiver believes the message is error-free. The retransmission method is used in the channels where the possibility of errors is small, because if we keep retransmitting the defected packets, there may be a greater chance of congestion. The number of errors is small in fiber optic cable transmission, so here, it is cheaper to use an error detecting code, and just retransmit defective blocks. FEC is used on noisy channels, where number of errors is high, because we cannot retransmit every defected packet, and errors may occur in the first retransmission also. Error correcting codes like FEC are widely used in wireless communications, since they are very much noisy, and error prone, when compared to optical fibers.